Hello, hi everyone. Welcome to the Student the Brand. So now we are going to discuss about electricity. Actually, yesterday some of the students asked about electricity explanation. So I missed. So now I'm explaining. I'm going to explain electricity chapter complete. Okay, chapter I'm trying. So I'll try to cover, including problems. So I'll try to cover the problems also. So you can join and try to learn and try to answer. See, the point is electricity we have to practice. Only when you practice, only you get the electricity chapter. Simply, normally, if you are listening, you may not get. Okay. So my suggestion is to everyone, try to involve in the chapter, try to practice the chapter, try to work along with me. Okay. So try to practice along with me. That is only method to nothing else. So we can't do more than that. So I'll be explaining on the board. You try to work out. So one by one. So step by step, whatever I'm explaining on the board. So practice along with me. Then automatically you'll get it. So other than that, there is no other to get this concept, to get the chapter. So today we will discuss about problems also. We will discuss the problems completely. So problems. Hello, hi everyone. Welcome to the Student the Brand. So now we will discuss completely about electricity problems theory. Okay, so combinedly I'll try to cover it because while entering into the problems, so it will take time. Okay, so continuously it goes on. So problems you have to work along with me. So theory anyway you are listening. Problems while I'm explaining, you have to involve. You have to involve. Then only you'll get it. So simply if you are joining and attending, so without practice, so you may not get. That is sure. So the concern is you have to involve. You have to involve at any cost. If you involve only with the chapter explanation, everything will get it. Okay, so notes also I'm giving. So try to notes, try to write the notes. So I'll try to give the notes along with the topic. Along with the topic, I'll try to give the notes itself. Okay, so try to work with me. Try to work with me. So some of the students in yesterday class, they asked, sir, explain the electricity chapter. So I saw the messages. Now I came forward to explain the electricity chapter. Okay, done. Shall we? Shall we start? Okay. Yes. So I hope visible to you. So I'm thinking board is visible to you all. Is it clear? Okay. Those who are there in the live class, those who are attending the live class, try to work out with me. Try to practice. So that is only request from my end. So shall we start? Okay. See here. Electricity chapter. Electricity or electric current we can say. electric current, right? So now you can observe. So I is nothing but rate of flow of charge. Rate of flow of charge. Flow of charge. So you can see. So many times students are asking about, sir, can you explain electricity? So more in detail. So what we'll get, how it will be. So what is SI unit, how you have to consider, how the problem. Here the point is, so many of students will concentrate on theory. Okay. So coming to the problem, so it's a little bit concern. The point is, so going with only theory will not give any result completely. So somehow we will get result, but completely will not get result. In the sense, in the exam, so when you are if you prepare and go theory, they'll give problems. If you concentrate on problems and go, they may give theory. So combination. So you must be with the combination. Okay, problems, theory along with the problems. Theory along with the problems. Then only you'll get success. Okay, so we'll work out. Try to write the notes. Okay, so we can see here I equal to I. So I is the current, Q is a charge, I is the current. Okay, Q is a charge. So I'm taking the charge, and T is the time. T is the time. The rate of flow of charge. The rate of flow of charge is called electric current. Rate of flow of charge. Rate of flow of charge. That is called electric current. I equal to Q by T. I equal to Q by T. I equal to Q by T. So rate of flow of charge. Simple definition. Simple definition is rate of flow of charge. Rate of flow of charge, or the flow of charge through unit cross-sectional area per second. So the flow of charge through unit cross-sectional area per second. So electricity, charge will move through like this, right? Charge will move through unit cross-sectional area only. So we will consider through unit cross-sectional area. So why it is like this? So area of the cross-section is nothing but this is the area of the cross-section. Area of the cross-section. Complete definition is, so the flow of charge through unit cross-section area per second. Unit cross-section area per second is called electric current. I equal to Q by T. I equal to Q by T. I equal to Q by T. I is the current. So Q is the charge. T is the time. I is the current. Q is the charge. T is the time. Right? Yes. So now you can see SI unit of current is what? Ampere. Ampere you have to write with ampere. So ampere you have to write with small letters. So we cannot write capital letters. Many of the students are doing mistakes. So in this area, so simply writing ampere capital letters. So losing marks. See, half mark, 1 mark. So if it is cut in one place, so in another place 1 more mark, in another place 1 more mark. They lose the compound marks compared to everything. Okay, overall results, it will impact a lot. So we can't get out of it. So there are many points are there. So there are many 100 points. Okay, so 100 points are there. So when you are working, so you must be careful. So how it will be there, how it is working, how it is going on. Okay, so with each and every point you should understand. So what exactly this one? So I equal to Q by T SI. So ampere we should not write capital letter. Starting word or starting letter should not write, because on honoring the scientist. Okay, so joule, ohm, and we can say ampere. All these units we are writing with the small letter. So starting with a small letter we are writing. So use the small letter itself. Clear? Okay. So like this I am taking. And here symbol we can take. Symbol capital letter. Symbol we can take capital. But so your word, so while writing word, you must be you have to write so ampere. You have to write ampere. Understood? So 1 ampere equal to 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 ampere equal to 1 coulomb per 1 second. 1 coulomb per 1 second. So define SI unit of current. Define SI unit of current. If they ask to define SI unit of current, how to define? How can you define? So definition, if they ask to define the SI unit of definition means, so 1 coulomb of charge flowing through unit cross section area per second. 1 coulomb of charge flowing through unit cross section area per second. Again 9 p.m. live class will be there. So 9 p.m. live class will be there. So you'll be having 9 p.m. live class. So join to the class. So electricity, we will work like a war. Okay, so we will work out all the points, all the definitions, all the problems. Actually, especially problems. We'll work out on problems also, because problems are very very important. Okay, so we'll work out on problems. So completely we are working now on electricity chapter. Yes or no? On electricity chapter we are working. Okay, so we'll see. Now we are 1 ampere equal to 1 coulomb of charge. 1 coulomb of charge flowing through unit cross section area per second. 1 coulomb of charge flowing through unit cross section area per second is called, what is that? 1 ampere. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So that is 1 coulomb, and 1 second, this is 1 ampere. So SI unit of current is ampere, SI unit of charge is coulomb, SI unit of time is second. Do you have any doubts? If you have any, okay, so we'll work out on it. Next, we are going with the one more. Actually, few points are available. Those points actually, like an index point of view. See, this is my notes. I did. So I have written my notes. So those who want notes, you can contact to that number. So each and every point in detail I have written. So you can check the notes. So this is my notes. Okay, handwritten notes. Those who want this handwritten notes, you can check. So very clearly I did. Very clearly I have written. So you can check here. You can check. Okay. So very clearly, so page to page, so point to point you can observe. So each and every point I mentioned, each and every detail I mentioned. So those who want, you can contact to that number. Okay. So I'll provide a best possible way. So you can check here. So each and every point, okay, simple and easy way I have written. So if you learn once this chapter, so you'll get it. You'll get complete knowledge about, complete idea about electricity chapter. So like this, and problems also I did 100 problems. Those 100, more than 100 problems are there. So we'll work out on 100 problems. So step by step, point to point, we'll work out. So the point is, you must work along with me. That is only thing, nothing else. Okay, so you have to work along with me. Then only you will get it. So surely again I'm saying, so if you work along with me only, you'll get it. That is a very important point. So if you have any doubts, you can ask me. So I'll explain. If not, we'll go to the next topic. Shall we go to next topic? Okay, done. Fine. So I'm going to the next topic. So electric current completed. Quantization of charge. So there are here, sir, basic points are there. Very very basics. I'm going to teach. So very basics I'm going to, okay, work out. So check once now. very much basics we are working now. So there are charge is a property of the matter. Charge is a property of the matter. Charge is a property of the matter which influence the presence of other charges. Charge is a property of the matter which influence the presence of other charges. Okay, so I am taking the charge. So charge first. So there are two types of charges are there: positive charge and negative charge. Positive charge and negative charge. Positive charge and negative charge. Okay. So positive charge and negative charge. Clear? Yes or no? So positive charge will repel, and negative charge also will repel. Positive charge will repel. Negative charge also will repel. And third point, so positive charge and negative charge attract, and negative charge and positive charge will attract. Okay, so very very important. So make a note of it. So be clear with the concept. So these concepts are very very important. So charge here, and positive is the proton, negative is the electron. Positive is the proton, negative is the electron. Okay, so be clear with that. Nice, correct. Now I am going with the another one. So positive is proton, negative is electron. So you can comment. So I may not respond to each and every comment, but definitely I'll see all the comments, then I'll respond. Okay, so you are saying hi to everyone. So you are not saying also fine. So hi to all. Okay, so if you are there in the online, try to like and share and subscribe. So try to like the video, so remaining students also they will get to know there is a live class is going on. If you have any doubts, you can ask me. So on one electron, how much charge is present means 1.6 into 10 power minus 19 coulomb. So on one electron, how much charge is present means. So actually, if you are taking, actually it is a charge on one charge. So if you are taking electron, minus symbol we have to take. Proton, if you take, positive symbol we have to take. So 1.6 into 10 power minus 19 coulomb. In 1 coulomb, someone is saying hi. Okay. hi to all. So like that I'm saying. Okay. So make sure that, again I'm saying, try to focus on the concepts, try to work out on the concept. Definitely you'll get it. So the point is, you must work out how you are getting, whether you are getting or not. So leave it about it. So try to focus. At least we can do focus, right? Leave it about the other things. So at least if you focus, you may get. So not now, after some time, at least you will get it, right? So the point is, final thing is, so by the board exam we have to work out. So we have to reach our full potential and get it done, right? That is only our target. So try to practice how many times if you are working. Okay, it's okay, fine, no problem. So maximum times try to work out. Definitely you'll get it. Vani toward high board. So what is the concern? Board, you can't able to see the board. So I didn't get it. Can tell me, Vani toward hut. So what is your concern? So you can't able to see the board, right? That's the concern. Okay, so if you are you able to see the board? Everyone are able to see the board? If not, let me know. Let me know. So if not, let me know. We'll work out on it. So on one charge, shade रहे shade okay. Okay, fine. Understood. Now you can see. Now it is clear. Now it is clear, Vani. Okay, fine. Let me know. So if any concern. Shading. Okay. Understood. Thank you, Sivani. Oh, thank you so much for giving confirmation. See, one electron if you are taking 1.6 into 10 power minus 19 coulomb. So 1 electron equal to 1.6 into 10 power minus 19 coulomb. On 1 coulomb. So on 1 coulomb. So in 1 coulomb, how many electrons are present? So 1 coulomb if you are taking this 1 by 1.6 into 10 power minus 19 you can take. So in 1 coulomb. So take this value down, then automatically you will get it. Okay. Then so you can see now 1 by 1.6 into 10 power 19. So very important. So damn sure question, compulsory you have to remember this value. Compulsory, without any doubts I am saying this point is very important. So directly in the problem they won't give this value, they won't give in the problem. Okay. Thank you, sir, Naresh. So uh, here this point is very important. They won't give in the exam hall. Never give. Okay. So directly, sometimes directly they will give hint. Okay. But we have to remember. This value. So on 1 electron 1.6 into 10 power minus 19 coulomb. And this value, so in MCQ's point of view, this value they will ask. So 1 by 1.6. 1 by 1.6 value how much? So if you solve it, you'll get a 0.625. You will get a 0.625. So try to solve it 10 by 10. So 10 by 10. So LCM you can do it. Okay, then you will get 0.625. I'm taking 0.625 into 10 power 19. So I'm removing 1 point. So 6.25 into 10 power 18. 10 power 18 electrons. Actually, this is the electron. So there is no units. So electrons number. That is a number. So very important. So MCQ's point of view very important. Make sure that you are learning this point. Very important. Highly important. Seriously, you have to take this point. Seriously, you have to remember this value. Practice twice, thrice, 5 times, 10 times, 20 times. How many times you can able to practice? Practice. But keep this in mind. Okay, how many times you are practicing? Simple one, nothing else, no need to worry about it. Simple point, 1.6 into 10 power minus 19 coulomb. So if you want the value, so see this value, simply we can take 6.25 into 10 power 18 electron. So this one in the exam hall also they will ask in the 3 ways. So question, see, same question, simple question. There are many ways they can ask. Actually in the problems it is there. So same question. I'll show you 3 ways. 3 ways they can ask the same question. 3 ways they can ask the same question. So very simple problem, very easy problem, but the way of asking is different. So in 1 coulomb of charge, how many electrons are present? In 1 coulomb of charge, how many electrons are present? They will ask. Okay. So how many electrons are present? So I equal to Q by T. So here quantization of charge is there. So one more point, quantization of charge. So I will explain now. Actually, when I'm standing here, so it is reflecting, taking place. That's why it is showing shadow. Don't worry about it. So when I'm turning like this, it is clear. Now 1 coulomb of charge you got to try. So these 2 points you remember clearly. So very carefully, these 2 values are very important. So here, if you know the process, it's very easy. Very simple, nothing else, no need to worry about it. Very simple point. Q by T, right? I equal to Q by T. I equal to Q by T. What is I equal to Q by T? The rate of flow of charge. Rate of flow of charge. I equal to Q by T. So flow of charge through unit cross section area per second. Flow of charge through unit cross sectional area per second is called electric current. What is electric current? Flow with me, along with me, repeat with me. So flow of charge through unit cross section area per second is called electric current. So simple definition, easy definition is flow of charge through unit cross section area per second, or simple definition as says, simple definition, what is that? Flow of charge per second, flow of charge per second. Or if you want to write clearly on the paper, okay, so on the in the exam hall, the flow of charge through unit cross section area per second, the flow of charge through unit cross section area per second is called electric current. Electric current, electric current. Repeat the words. See, if the words are very difficult to pronounce, the words are okay, somehow you can't able to recognize the words, means repeat many times, electric current, I equal to Q by T. So after that, after the class, while going the corridor, we're going in some other way, so electric current, electric current, don't shout like that. So in your mind, when you are reading, when you are studying, that time, so you can keep quiet. Okay, so maintain your silence. So take your place and be calm, relax yourself, and take the concept. So reading, writing gives extremely extraordinary results. Simple. See, there are many ways. One person will read simple. Okay, so easy way they will learn. Another person, they have to write. Okay, some people they will write. But the thing is, when you are reading and writing, your muscle will work. Okay, muscle force will work, muscle strength will work. Because of that, blood flow will be there. Because of that, so nerves in our mind will activate automatically. You can remember very well. We can remember very well. So reading and writing gives the best results. Okay, and after some time you have to repeat the process, same process you have to repeat. Simply so I completed, so that's enough, so leaving like that, no, you must work out. Okay, so do you have any doubts? Okay, it's fine, no problem. So I'm considering here, so quantization of charge, say simply we can say like this, I'm taking. Okay, so in the conductor, electrons will not move alone. So do you observe, electrons will not move alone. So number of electrons, a bunch of electrons, a bunch of electrons will move. Number of electrons will move. It is not a single one. If a single electron will move, so we cannot say current is flowing. Number of electrons are flowing. Number of electrons are moving. That is called quantization of charge. Number, integral, multiple. So electrons will move in the conductor in the form of integral multiple. Many electrons will flow. Actually, electrons will move from negative terminal to positive terminal. So electric circuit, when electric circuit and electric circuit comes, that time I will explain. We have to discuss electric current and conventional current. There are two types of currents are there. So electric current and conventional current. Conventional current means flow. So protons direction, flow of positive charges we are taking. Still we are using the same. In our textbooks you can see, observe, the direction of the current will be taken from positive terminal to negative terminal. But actually electrons will move from negative terminal to positive terminal. So I will show you the direction. That time we'll see. Now number of electrons will move. Number of electrons will move, right? Number of electrons will move. Integral multiple. So here positive charges also there. Positive charges also there. Okay, that's why plus or minus q equal to plus or minus Ne I am taking. Plus or minus integral multiple of electrons. So positive charges are, negative charges are there, positive charges are there, negative charges also there. So that's why the movement of positive charges and negative charges, because of that reason, so the current is flowing in the conductor. Because of that reason, the current is flowing in the conductor. So that's why q equal to plus or minus Ne. So then here I am taking, so as you can see, this is a quantization of charge. As I said, electrons will not move a single 1, 2 like that, it won't move. It will move like a integral multiple. Number of electrons will move, number of charges will move. So that's why plus or minus Ne. Why we are taking plus or minus? So protons will be there, electrons will be there. So proton we are taking positive sign, electron will be taking negative sign. That's why quantization of charge we are considering plus or minus Ne. Okay, plus or minus Ne. So I equal to plus or minus Ne by T. So plus or minus Ne by T. So plus or minus Ne by T. So Q I am considering. Here you can see I equal to, simple we can take if you are taking electron. If you are taking electron, so Ne by T. So negative sign we can take. So simple value only we are considering, that value only we are considering. Flow of positive charges. Current, what is the definition of the current? So actually the flow of charges we can say. Flow of charges. But actually if you are taking current, there are two types of current: conventional current and electric current. Conventional current and electric current. So here I am taking normal conventional current, that is nothing but flow of positive charges. So I equal to Ne by T. Ne into, so as I said, in 1 coulomb of charge, how many electrons are present? How in 1 coulomb of charge, so electrons are moving. Okay, charges are moving in the conductor. Okay, charges are moving in the conductor. How many electrons? How many electrons we have to take? So for saying the 1 coulomb, when you in 1 coulomb, so that is what I am saying. So that is what we are working on it. I am trying to say here in 1 coulomb. So current I am considering 1 ampere. I am taking 1 ampere. Okay, so 1 ampere I am considering here. So n value we have to find out. So our main target is to find the n value. So time is t only, that is 1 second. So 1 ampere current. So I'm rubbing this one. So just check once. So here 1 ampere current. So there are different kinds of questions. I said now I equal to q by t, that is nothing but Ne by T. So I want 1 ampere current means 1. I am taking n into, as I said, this value you have to remember. What is this value? Can anyone say this value? What is this value? E value 1.6 into 10 power minus 9 coulomb by, so here how many times? So 1 second. So now I want n equal to, so you can take 1 by 1.6 into 10 power minus 19. So that is nothing but 1 by 1.6 into 10 power 19. So it will comes up 19, you will get it. So that's why I am taking 19. So 19. Now, so if you do it, you'll get it 0.625 into 10 power 19. So if you remove one value, so 6.25 into 10 power 18 electrons. So electrons I'm taking. So this is the value. This value is very, very important. Again, I'm saying this value is very, very important. Keep this one in mind. This one also. These two values are very, very important. So on 1 electron, so how to remember, on 1 electron how much charge is present? On 1 electron how much charge is present? So 1.6 into 10 power minus 19 coulomb. In 1 electron how many in 1 coulomb how many electrons are present? In 1 coulomb how many electrons present? It is huge, right? 6.25 into 10 power 18. It's very huge. 6.25 into 10 power 18. 10 power 18. Remember, no, just you can draw, you can mention the values, zeros. Zeros you can take. So if you take two zeros, 10 power 16, 625. After 625, 16 zeros you have to place. 16 zeros. Okay. So 0, if it is there this side, there is no value. Actually 0 is there. If you are taking 0 this side, there is no value. But if 0 is there this side, there is a value. Okay. So 0.1, 10. So much difference, right? This is first rank. This is 10th rank. Of course, there is a value. Okay, done. Come to the point. Next one. Electrical equipment, electrical appliances, I'll teach. Electrical appliances. Electrical appliances. Electricity chapter. So, electricity chapter. Okay. So, here, this is what, this is I am taking positive terminal, negative terminal, first one. So, this is cell. Next one, battery. Battery. Third one what I am considering, bulb. And fourth one, switch. This is open switch. This is open switch. And fifth one is closed switch. Nothing else. This is closed switch. Simply dot is there. Closed switch. And sixth one, resistor. Resistor. Seventh one, rheostat. Rheostat. This is rheostat. Rheostat. So resistor, rheostat. Okay, next one, ammeter. So make a note of it. I hope it is clear to you all. At least if who are there in the live class say yes or no, I'll feel happy. At least I will continue the next topic. La 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 la. So here you can see seventh one. Seventh one you can observe. Seventh one. So resistor, rheostat, ammeter, positive terminal, negative terminal, voltmeter, right? Ammeter and voltmeter. That's enough. Any other points? Any other points? Any other points? One more point. Two more points. Two more points. So I am considering this is wire joining. How it is? Wire joining. Next one, wire crossing. This is wire crossing. Wire joining ammeter and voltmeter. Wire joining. This is wire crossing. Clear? Any doubts? Do you have any doubts? No one? Okay. So wire joining, wire crossing completed. Next, electric circuit. I said conventional current and electric current. So electric we discussed. Now electrical circuit. A continuous and closed path of an electric current. A continuous and closed path of an electric current is called electric circuit. Okay. So here, see from this you can observe that from here the flow of positive charges is called conventional current. Conventional current. This is called electric current. Electric current. Electrons will move from negative terminal to positive terminal. Protons will move from positive terminal to negative terminal. Protons will move from positive terminal to negative terminal. Electron will move from negative terminal to positive terminal. So what is the conventional current? The flow of positive charges is called conventional current. Okay. So what is the direction of conventional current? The flow of positive charges direction is taken as conventional current direction. Okay. What about electric current? The flow of electrons. What is that? The flow of electrons. What is that? Once again, the flow of electrons is called so you can contact to this number. Those who need the physics notes, so you can contact this number. So say hi. Okay, I'll reach to you. Someone said notes. So if you want, hey, final hour. How are you? I'll sing one song with your permission. Shall I? My favorite song. Sir, why you are doing all these things you can teach normally? It's not possible. Not at all possible. It happens. Okay? Rain we can't stop. No, we have umbrella. That's okay, fine. For our protection. But we can't stop the rain. We can't stop this running, okay, and we can't stop the natural things, okay. So like a day and nights and seasons, like this also in teaching. It's a part of teaching. It's a part of teaching. It's the art of teaching. It's a passion. It's okay, sir. Come to the point. Will shall we sing? Shall I sing? Say yes or no. At least who are there say yes, sir. I will sing the song. Myopia song. Myopia. Actually, it is my favorite song. Oh, it's years on years continuously going on. So little bit break, no, continuously if you are going on, some break is required. Okay, some break is required. Myopia, 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 myopia. Near distance we can see a far distance we can see a myopia, myopia, myopia. For that correction we are using, bro. What, bro? For that correction we are using concave lens, concave lens, concave lens, concave lens. So, likely it's going on. So it goes on like that. So I did many songs. I created many songs on subject like hypermetropia, 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 hypermetropia. Far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For that correction, for that correction, we are using, we are using convex lens, convex lens, convex lens, convex lens. So actually, initially, no, like why I started singing this. Thank you, thank you, thank you so much. So generally, what we can say, this is a motive. It's like a motive. So initially, while I'm teaching the physics subject, especially this grade 10, near to the myopia, so few students are getting confusion. What is hypermetropia? Which lens we have to use? Like that. So I thought a lot. So you can see my YouTube channel. You can go to the playlist. Uh, there are many videos, experimental videos I did. Okay, so take time. It takes time. So great things it reached to the people very late. Maybe. So I'm expecting. So I'm hoping that. So it reached to the people. So I'm thinking. So you can observe. There are many videos, many experiments. There are many experiments in physics. So I did. Still I'm going with that. So still I won't stop until these things reach to the people. Okay, so that is my goal, that is my ambition, that is my passion. So more than that, and the more than that. So iMovie. So more than that. That's enough. Okay, come to the point. Next, actually, one more song related to sign conventions. Small break I'm taking. So those are waiting for the subject. Surely I'll teach. So one more song uh, we wish you let full interphysics NEET classes also, intermediate classes also I'm taking. So anything you want, so just you can contact this number. Okay, so you can contact this number. Definitely you'll get it. Definitely you'll get the right answer. So according to me, so hoping that so you'll get the right answer. So reach to the point, reach to the final point. So this is the final point. So you can reach to this WhatsApp number. Okay, so you have WhatsApp. We have WhatsApp on it. You can reach to that. So we'll see. Okay, then we'll work out on it. We'll work out on it. Those who want. So please make more two people speaking in YouTube shots. Yeah. So that is going on. That is continuing. Will you tell interphysics also? Yes, Satvik. Yes, Satvik. You can reach to the. You can reach to me through that phone number. So this is the phone number. You can. Okay, done. So one more song. Shall I or shall I go to the next? So how many are says yes? How many at least like at least sir? Yes sir, yes sir, yes sir. Like that at least. If you comment, no, I'll feel. Say in the class, if I ask, so everyone will raise a hand. So like a singing. At least you hear. At least someone says yes, yes. At least say yes. Then I will continue the one more song. One more song I'll continue. Then I'll go to the subject. Shall I? Shall? No one. So some are saying, okay, I'll take a test. New Cartesian sign convention. New Cartesian sign convention. All the distance measure from the pole. Distance positive along the instant race. Distance negative opposite to instant race. Distance positive above the principal axis. Distance negative below the principal axis. Clear? New Cartesian sign convention. New Cartesian sign convention. All a distance measure from the pole. Distance positive along the instant trace. Distance negative opposite to instant trace. Distance positive above the principal negative below the principal axis. This no, whatever I am creating these songs, just for remembering sake, we can remember in easy way. Okay, so in a simple way, easy way, so you can remember. Okay, if you're the final point is so understanding the concept, remembering is the thing, and we have to write. Okay, so an example. That's why I'm creating all these ways, all this attain no to what we can say attention seekers, like to take attention, to grab the attention, to focus on particular thing. So immediately see, if you fully focused on one thing, you can remember very well. So like a movie, you can say it's a picturization. So action, background music, dun, 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 like that. See, okay, so if I take the action, like the background music, dun, 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 like that. See, that time what you will feel something like internally. So without our motive, so we'll focus on that. Yes, I know. By like this. So here also same thing. So to make the subject more interesting, so I'm creating all these things. So if you like this video, if you like this content, please do like, share and subscribe and share to everyone. So remaining members also they'll get to know, remaining students also they'll get to know. So remaining students, those who want to really, those who are there in need. So if this type of videos relate, really content videos, really whatever I'm creating, I am working on particular content, okay, on one content. So my motive completely focusing on one content, that is physics. Okay, so that if on physics only I'm working on it. So to create more so innovative way, creative way, so better way how this content can reach to the students in a better way, better possible, more, so in a more innovative way. Okay, that's what I'm thinking, that's what I'm planning. It's okay, fine, come to the point. Next one, we'll go to the concept. So conventional current and electric current, conventional current and electric current. So conventional current, I'm considering conventional current. Conventional current is nothing but the flow of positive charges. The flow of positive charges. Positive charges will move from positive terminal to negative terminal. Negative charges, that is nothing but electron. Electron will move from, so negative terminal to positive terminal. So flow of positive charges is considered as a conventional current. So flow of electrons is considered electric current. So is it clear, everybody? Done, fine. Then I'm going to the next topic. Okay, so this is the conventional current and electric current. See, electric current, it won't complete because it will take time. So we need to work out an electric current. So problems are there. So many problems are there. Okay. So now what is the time? So 12:30. So by 1 o'clock, I will end. So next again uh, 3 o'clock. 3 o'clock I'll start a live class again. So join to the live class. So we'll see now. Okay, 3 o'clock I'll take again live class. So meanwhile you can work out on the subject. You can work out on subject. 3 o'clock I'll take. Okay, so few more points I'll take discuss. So then we'll go to the final end. So here 1 milliampere equal to 10 power minus 3 ampere. So 1 microampere equal to 10 power minus 6 ampere. So very important. 1 milliampere. See here. One of the student did one mistake. That is, so he thought it is micro. So like M is there, no? So in that way, so how we are writing the words micro. So he thought like that and he did. So 1 mark lost. So milli this is one is a micro. So remember the symbols. Generally they will ask about this type of questions. Basic questions they will touch. Whether you are able to do it or not. Okay. Then fine, next. I am considering next one more. Potential difference. Shall I go to that potential difference? Yes, potential difference I'll explain. Potential difference. Potential difference. Potential difference. I'll give one example. Two beakers. So this is one beaker. This is one more beaker. So we place this two beakers at the same level. So level is same. So we fill the water until here. So same level. So I connected. Okay. So I connected like this. So I connected like this. Okay. So will water will flow? will this water will flow from one beaker A I am considering. So I will consider this is beaker A and beaker B. Will the water will flow? Water will flow from beaker A to beaker B. I am in live class here. So you are there. Okay, check once. So you can see here. So water is flowing from here to here. Okay, water will flow? Water will flow? No, water will not flow. Water will not flow because so we are placing at the same level, right? We are placing at the same level. Water will not flow. Water will not flow. So the same situation like this. Same situation you can take. So here one beaker I kept certain height below the A. So I'm taking here, this is certain height and this is certain height. Okay. So and now I'm connecting. So water is there. Now I am connecting like this. Will the water flow from A to B? Say yes or no? Yes. Water will flow from A to B. Water will flow from A to B. Yes. Now it will flow. Because height difference. So some difference is there. So you concentrate on it. Gravity, anyway, gravity is different. So gravity will act on each and every object. Okay, gravitational force will be there. But still some height difference is there. Because of height difference, the water will flow. The water will flow. Okay, because of gravitational force. Anyway, some difference. Simple way to recognize this one is, simple way is, some difference is there. Some difference from here to here, here to here, here to here. So same principle we will use here. We'll use. So here in this conductor, this is a conductor, this is a conductor. So here is positive charge here. So A to B, so positive charge. Will the current will flow? Current will flow from A to B without connecting anything, without connecting to the circuit, without connecting. So take a wire, normal copper wire. Will current will flow from A to B? No. So we have to connect. What is that? Battery. If you connect battery, so here if you connect battery, so battery gives that. Battery creates the difference. Here more potential, here less potential. So the electric charges will move from low potential, high potential to low potential. High potential to low potential. And here is one point. Proton will move from high potential to low potential, but electron will move from low potential to high potential. Low potential to high potential. So here one more question. How the potential difference? So analog to temperature. Temperature will move from higher temperature region to lower temperature region. Here also, so charges will move from higher potential to lower potential. Higher potential to lower potential. So work done. We are doing some work. We are doing some work to bring, to bring charges from higher potential to lower potential. We are doing some work to bring charges from high potential to low potential. I am taking like this. Here you can see. So potential difference is nothing but, so here is A and here is B. Okay. So positive charge is there. So Q. So we are doing some work. So V equal to W by Q. V equal to W by Q. Work done on unit positive charge to bring from point A to point B. To bring from point A to point B is called potential difference. Electrical potential. Electrical potential means, so we are doing some work to bring charge from infinity to the required field. This is the required field. Charge is there here. We are doing some work to bring charge from infinity to the required field is called electrical potential. electrical potential, electrical potential, electrical potential. So that is the potential difference, this electrical potential. So any doubts? Do you have any doubts? Clear? Potential difference, some height difference is there, that is potential difference. Okay, so that is about electrical potential and potential difference. So that is today class. It's about today class. Here, SI unit of potential difference is volt. SI unit of potential difference is volt. SI unit of work is joule. SI unit of work is joule. SI unit of charge is coulomb. SI unit of charge is coulomb. That's enough. So that is about today class. Still, still it is there. So 3 o'clock again I'll take the class. 3 o'clock. So 3 p.m. live. 3 p.m. live will be there. 3 p.m. live will be there. So that time I'll teach continuation like Ohm's law. Ohm's law I'll discuss. I'm giving break for lunch time. So take lunch break and relax. So take lunch break and relax. So we'll work out on it now. Nearly it's going to 1. So take lunch break and relax. So 3 p.m. again. Resistors are in series, resistors are in parallel, and heating effect of electric current and applications. After that, we'll go to the problems. Few problems we'll discuss. So that's enough for now. So thank you so much. So please do like, share, and subscribe if you like this content. So thank you so much.